we can exactly find the definite integral. Find antiderivative, plug the top, b, upper limit of integration, minus, plug the bottom, a, lower limit of integration. Why did we do rectangles then? Sometimes integrals cannot be integrated. They're integrals that mean important things. Cancer spread, space science. There are lots of integrals which are too hard to integrate. And there are several tricks how you do it. Trick number one, you take them to the complex variables world called complex analysis and use tricks there. So complex, we remember I square root of -1. Complex numbers actually have the whole world called complex analysis. So surprisingly, it's like a whole different imaginary world, literally imaginary. You take integral there, convert it, integrate or differentiate whatever you need to do there using their functions and their properties. Convert it back and get the result. So that's a very classical thing we teach in graduate school. And then the other way is using series expansions. We're going to do that in calculus 2. And the other thing is numerically, which we learn through rectangles. In calculus 2, there will be trapezoids, parabolas, and so on. Numerical integration is a whole study, how to do it numerically. But it doesn't give you exact answer. So Fundamental Theorem of Calculus Part 2 is amazing, partially because it gives you the exact answer. Let's practice a little bit more. Those problems should be your favorite problems on the test, unless you just did not do any homework. If you do homework, you know what is happening. If I want to find definite integral of 4 e to the x plus 4 sine x dx equals, the theorem says, for now, ignore the definite integral limits of integration and just find antiderivative. To find antiderivative, you answer the question, what gave me 4 e to the x when you differentiated that? What was it? 4 e to the x, right? Plus c. And we don't write plus c for the definite integral. Definite integral is when a and b are defined. What gave me 4 sine after differentiating it? I definitely remember it's cosine, and my job now is to figure out the sine of that cosine. When I differentiate 4 cosine gives me minus 4 sine. To fix that, I put minus. So I recommend you don't have to follow my way of learning, but I did not learn the second part. I only learned differentiation. So every time I just check myself, and it becomes a habit, and then you get used to it. Now, notation, let's review notation again. Parentheses or not everyone put parentheses, bar 1 and e. That's the result of definite integration. Instead of plus c, you put a bar. In American books, you will see a bracket often, but internationally, people know a bar. And it means from 1 to e. You always go from 2, from first floor to e floor. So the idea is plug everywhere you see x, the top, minus plug everywhere you see x, the bottom. So 1, e goes first, equal sign. I'm plugging e everywhere I see x, e to the e, that's a number. Don't be scared. It's 2.7 something something raised to 2.7 something something. Minus 4 cosine of e, that's also a number. Cosine of 2.7 something something. Now I do minus, because it's part of the formula. We are scanning. Remember I made example with a CAT scan. So from A to B, and then from top minus bottom. How to find top from bottom? The difference between top and bottom is minus. Top minus bottom. That's why it's smart to put parentheses like so. I will change the color to green. And now I plug everywhere 1, 4 e to the 1, minus 4 cosine of 1. Cosine of 1 is also some kind of number. And this is the answer. This is the answer. No need to simplify anything in this case. You can factor out things. And if you do want to distribute a negative sign, be careful with it. It's minus plus. So be careful. That's why these parentheses matter so much. All parentheses usually matter a lot. Do you understand that that's all we want you to know for this class? In Calculus 2, it becomes more complicated. Calculus 3 is going to be much more interesting. But for now, this is all we need you to know. Integrate Antiderivative, plug in minus, and don't mess up algebra, your biggest enemy. Questions? So again, to make an explanation of this, I plotted this function in Wolfram alpha. And Wolfram alpha factored out 4, but did not simplify anything else, as it should not. And it told me it's approximately 55.55. That's a cool number. Approximately 55.55. Remember, it's an area. It's an area, and here it is. I plotted the function. And then we wanted to find integral from 1. I don't know why it's so close to 0. That's kind of dumb. So it's like, it's not 0. It's from 1 to e, and e is approximately 2.7, right? And this is the area we found using this integration. And area is only one of the applications. There's so much more to that. Does it make sense? Let's do one more. So you have one of these problems right now on the quiz. I just put one easy one, just to make sure that you know that we're doing it. On the exam, we will have several. Let's do one more. That is dangerous. 4, I think it's 4. From 0, make sure your integral sign is beautiful. My eyes bleed when I grade the exams and your integral is like this or like this. It's just nicely stretched letter S, if you want to see that way. Just make it beautiful. Find the artistic side of your personality, at least for the integral sign. 2 over 1 minus x squared inside of this square root. You know what I forgot? Don't forget the x, or else it becomes inappropriate. So clever. I'm so proud of myself. Some inside joke. You will not believe, but I actually do meet students who I never met, but they were watching my videos for Calc 1, 2, and 3. And now they're like seniors and like, you are Professor Julie, right? I loved your joke about that integral. Oh, in the hedgehog example in Calculus 2 video you made? It's hilarious. I'm like, whoa. Like, so they know all my jokes just because they watch my videos. I made lots of interesting jokes throughout Calc 1, 2, and 3. Interesting, that's like very subjective, of course. So, I don't know how to integrate that. That's hard. So I always recommend you to take the constant and kick it out. Properties of integrals allow you to do that. 2 will be outside because it's multiplied, right? So let's kick it out. From 0 to square root of 3 over 2. And now it will be 1 over square root minus 1 minus 1 over square root 1 minus x squared dx. And now you stare at this. In Calculus 2, we're going to learn use substitution integration by parts, trigonometric substitutions, and partial fraction decompositions to solve all of this kind of stuff. But right now, we don't give you anything more complicated than just answering the question. When you differentiated something, what gave you 1 over square root of 1 minus x squared? It rhymes with... Wait. I'm trying to figure out what it rhymes with. It rhymes with... Sine. That's not interesting at all. Oh, it rhymes with mine. Very clever. Arc sine. Yeah, I like that. Do you remember? So 2. And now you have arc sine, or some of you said sine minus 1. That's correct, 2. Arc sine of x. So it means you just need to remember differentiation formulas in order to do these. And now there's a bar. Now it's not going to fit. A bar from 0 to square root of 3 over 2. 0 square root of 3 over 2. Arc sine takes a number in and spits out an angle. Unlike sine takes in a number, radians or degrees, and spits out the distance. Then arc sine spits out the degrees, basically. That's the idea. So you plug the top and then minus plug the bottom. It's all the same. And we don't even require you to simplify it. You don't have to. You can plug it into Weber work and it will accept this answer, even though you're kind of supposed to know what sine of what angle gave you square root of 3 over 2. See, it's inverse process. Sine of what angle gave you square root of 3 over 2. Do you know? Does anyone know?
the pi by 4? I'm not sure.
Power 3. Yeah, power 3. Close. So it's going to be 2 times pi over 3. And now we're going to have a second part. And second part is 2. Don't forget, either have 2 outside, like so, or repeat it again, because it's multiplied. Minus 2 arc sine of 0. And guess what? You also ask the same question. Sine of what angle gave you 0? 0, and then pi, 2 pi, and so on. So I'm going to write down 0. So it becomes, oh, that's 3. Sorry about that. 3. 2 pi over 3 is the answer. Why we did not choose pi or 2 pi and so on? We were learning this when we taught you inverse functions. So inverse tricks have restricted domain. And because arc sine has restricted domain, you can only use 0, not pi and 2 pi and so on. We're restricting it. It's fine. You can check the chapter of trigonometry inverse tricks. See inverse tricks. Okay, so the number is 2 pi over 3. It's kind of awkward. Like, what does it even mean? Still, if I draw this function, if I plot it, the area below the graph of this function from 0 to square root of 3 over 2 is 2 pi over 3, which is some kind of number. It's 2 times 3, 14, 59, something. You can cut off somewhere, divided by 3. So it's some kind of area. But again, we always keep mentioning areas. It's only one of the applications. We're going to have more and explain you more. And you already know, from acceleration to velocity, integration. What if I want to find velocity from 1 second to 15 seconds if acceleration is given? Integrate from 1 to 13. So that's a very classical example. What do you think about that? What do you think about that? Questions, ideas, suggestions? Critics, comments, praises. Which reminds me, Max show up. We should praise Max for amazing work. Well, this might be the last time we see him, because on Friday he's not going to come. We don't have quiz. Thank you so much for your help. Yay. Yeah. We were lucky to get Max in our class. He's a very good tutor and teacher and just very compassionate person. Professional also. That's very good. I like it a lot. I'm not sure if you're going to get him next time because he has class during our class. But it would be nice. Once I had the same IA for all 3 calculuses. It was so cool. People just became big friends after that. So that's what kind of I want you to know how to do, and that's what your homework is. Can you do this homework? So now it was extended. If you're late, I extended your homework to be due Sunday because you have deadlines due Friday. So I decided to help you out with that. That's what I wanted to show you.